Welcome to G Fun Facts Online. For almost all of human history, everything we studied in space was a local affair. Planets, comets, asteroids, all born from the same cosmic dust cloud as Earth. But what if a piece of another distant star system paid us a visit? What could a messenger from another world tell us? Well, this isn't a what-if scenario anymore. In 2017, it happened. We detected our first visitor from interstellar space, and it kicked off a revolution in astronomy. Today, we're talking about these cosmic messengers and the secrets they're revealing about our galaxy. It all started on October 19, 2017. The Pan-STARRS 1 telescope in Hawaii, designed to spot asteroids that might threaten Earth, picked up a faint point of light moving incredibly fast. Astronomer Robert Warwick was the first to realize this was something special. Its path wasn't a normal elliptical orbit around our sun. It was following a steep hyperbolic path. In simple terms, it was moving way too fast to be captured by the sun's gravity. It was just passing through. This was it, our first confirmed interstellar object. It was given the name ʻOumuamua, a Hawaiian name meaning a messenger from afar arriving first. And this messenger was deeply weird. As telescopes all over the world scrambled to get a look, a bizarre picture emerged. First, its shape. Based on how its brightness varied, astronomers calculated it must be highly elongated, maybe 10 times longer than it was wide. Think of a cosmic cigar, or perhaps a very flat pancake. We've never seen anything like that in our own solar system. But the biggest mystery was its movement. It showed a slight acceleration, a gentle push away from the sun that couldn't be explained by gravity alone. This kind of rocket effect is common in comets. As they get close to the sun, their ice heats up and turns into gas, pushing the comet along. The problem? Oumuamua had no visible tail. There was no coma of gas and dust. So what was pushing it? The peculiarities of Oumuamua sent scientists into a frenzy, with theories ranging from the plausible to the truly extraordinary. One of the leading natural explanations is the nitrogen iceberg theory. The idea is that Oumuamua could be a fragment chipped off a Pluto-like exoplanet, a world rich in frozen nitrogen. As this nitrogen iceberg got close to our sun, the nitrogen would sublimate, turn directly from solid to gas. This outgassing would be invisible to our telescopes, but it would provide the gentle push needed to explain its acceleration. This theory also neatly explains the strange shape. As the iceberg traveled through space, it would erode like a bar of soap, becoming flatter and thinner over time. But there was another, far more headline-grabbing theory, championed by Harvard astronomer Avi Loeb. He proposed that Oumuamua's unique characteristics were consistent with it being an artifact of an extraterrestrial civilization. Loeb pointed to its extreme shape, its weird acceleration, and its unusual trajectory, and suggested the simplest explanation might be that it was a piece of alien technology. Perhaps a solar sail, a type of craft that uses the pressure of starlight to move. He argued that if it were incredibly thin, less than a millimeter thick, the sun's radiation could have pushed it exactly as observed. This idea, as you can imagine, was met with a lot of skepticism. Most astronomers argue that while Oumuamua is definitely unusual, a natural explanation is far more likely. After all, you should NT jump to aliens when you've only seen a single example of a new phenomenon. Radio telescopes listened for any signals from the object, but heard only silence. The debate continues, but one thing is certain. Our first interstellar visitor challenged everything we thought we knew. Then, just as the dust was settling, the cosmos sent us another messenger. On August 30, 2019, amateur astronomer Gennady Borisov spotted a new object. It was quickly confirmed to be our second interstellar visitor and was named 2I Borisov in his honor. And Borisov was the exact opposite of Oumuamua. It looked normal. It was clearly a comet, with a fuzzy coma of gas and a long tail. In fact, It was exactly what most astronomers expected our first interstellar visitor to look like. The discovery of a normal interstellar comet was hugely important. It suggested that maybe the building blocks of other solar systems aren't so different from ours after all. And because Borisov had a visible coma, scientists could do something they couldn't with ʻOumuamua. They could analyze its chemical composition. By using a technique called spectroscopy, which splits light into its chemical fingerprints, they could see what Borisov was made of. What they found was fascinating. On one hand, it was familiar. It had molecules like hydrogen cyanide, just like our own comets. But it also had a huge, unusual amount of carbon monoxide. Up to 26 times more than the average comet in our solar system. This high concentration of carbon monoxide tells us that 2I/Borisov must have formed in an extremely cold place, with temperatures below -250 degrees Celsius. That's colder than the regions where our own comets form. This suggests its home star system might be very different from ours. Perhaps it formed around a red dwarf, a star much smaller and dimmer than our Sun. So while Borisov looked familiar on the outside, its chemistry told us it was a product of a distinctly alien environment. And the discoveries haven't stopped. In 2025, a third interstellar object was confirmed, named 3I/Atlas. It also appears to be a comet, and a big one at that, possibly up to 20 kilometers in diameter. Each new visitor gives us another precious data point, another piece of a galactic puzzle. These objects are revolutionizing our understanding of the cosmos. For the first time, we have actual physical material from other star systems that we can study. They are the leftover building blocks of exoplanets. By analyzing them, we can learn about the chemical diversity of planetary systems across the galaxy. And the fact that we've found 3 already suggests that the space between stars is teeming with these nomads. Some estimates suggest there could be thousands of ʻOumuamua-sized objects passing through our solar system at any given moment. We're just now getting the technology to spot them. And that technology is about to take a giant leap forward. The Vera C. Rubin Observatory in Chile is set to begin operations soon. This incredible telescope will scan the entire southern sky every few nights, and it's expected to find not 1 or 2 interstellar objects, but dozens of them every single year. We're about to go from a few puzzling examples to a whole catalog of cosmic visitors. And we're not just going to watch them from afar. The European Space Agency is preparing the Comet Interceptor mission, scheduled for launch in 2029. This spacecraft will park itself in space and wait. When a new interstellar object is found on the right trajectory, the interceptor will be sent on a mission to fly by it, giving us our first ever close-up images of a messenger from another star system. The arrival of these cosmic travelers has fundamentally changed our view of the galaxy. We are no longer an isolated island. The universe is a place of exchange, where the pieces of distant worlds can wander into our own cosmic backyard. Each new object is a gift, a tangible piece of evidence about the vast, interconnected nature of the cosmos. They are letters sent from other stars, and for the first time in history, we are finally learning how to read them.